Welcome back to Basic Mathematics. In this video, we're going to be looking at fractions and mixed numbers. We've already studied fractional values in terms of decimal numbers, and decimal numbers are very nice in a computer-driven sense. Decimal numbers are numbers that computers and calculators can handle very readily. But they actually make calculation by hand very difficult. And being able to do quick calculations by hand is a valuable skill in its own right. And that's where fractional values come in. Fractions are a different way of representing numbers between 0 and 1 that allow us to do calculations by hand a lot more readily than trying to do things with decimal numbers. So let me get my head out of the way and let's look at something that doesn't really feel like an example at all. In the US customary system, we traditionally measure lengths and heights in mixed units of feet and inches. So for example, the ceilings in the room where I am currently recording this video are 7 feet 5 inches high. If I needed to do calculations with that, I would find the mixed units here to be very cumbersome. And so usually we take the time to rewrite 7 feet 5 inches or whatever mixed measurement in terms of just inches before we do calculations. So I know that there are 12 inches in 1 foot. And if I multiply 7 feet times 12 inches in 1 foot, I get that 7 feet is the same thing as 84 inches. So my measurement of 7 feet 5 inches is the same thing as 84 inches plus 5 inches, which is 89 inches. But just like I can convert and say that there are 12 inches in 1 foot, I can say that there is 1 foot in 12 inches. So 5 inches is 5/12 of a foot. And 89 inches is 89 over 12 of a foot. My measurement of 7 feet 5 inches is the same thing as 7 and 5/12 inches. My measurement of 89 inches is the same thing. I'm sorry, got inches on my brain. 7 foot 5 inches is 7 and 5/12 feet. 89 inches is 89/12 feet. And while those are not very useful measurements as far as actually looking at the world, they do give us a nice representation. When we combine whole numbers and fractions, like we did right here, we call that a mixed number. When we have a fraction with a bigger number on top than on the bottom, we call that an improper fraction. As a general rule in the world, mixed numbers are very useful for describing situations. Improper fractions are very useful for doing calculations. So being able to convert between them using basically the process that we've just talked about here for converting between feet and inches is a very valuable tool. We know, we've established well in the past that fractions mean division. If I have a over b, I'm really saying that I want to do a divided by b. We call the number on the top of the fraction the numerator, and we call the number on the bottom of the fraction the denominator, right? So numerator, denominator, the line that divides everything up is called the fraction bar. We've used fractions as grouping symbols and done calculations around them before. There's nothing new going on here. The only thing that's new is that now we can write our fraction, excuse me, we can write our, the only thing new going on here is that we can write our fractions in one of two different forms when we have numerical fractions and the division doesn't work out evenly. So if I have an improper fraction, like 63 over 8. Well, 63 over 8 means 63 divided by 8, which I can set up in long division. 8 fits into 63. Well, that doesn't quite work out nicely, right? 8 times 8 is 64, so we're too big there. I guess we're going to have to go with 8 times 7, which is 56. Subtract that off. 63 minus 56 is 7. This 7 becomes the numerator of the fraction, and then the denominator is the same denominator we had before. All right, so by writing a number as a mixed number fraction instead of trying to go with a decimal, we can deal with terminating and repeating decimals a lot more readily. We don't have to worry about how far out we're going to have to expand. We don't have to worry about rounding. And if we want to go the other way, we kind of have to think through that backwards. Fractions turned into division. Opposite of division is multiplication. So if I have a number like 5 3/7 that I want to turn into an improper fraction, well, I know I wanted 7 goes into something 5 times with remainder 3. So that means I want to subtract from this something 35 and get 3. All right, that's a really roundabout way of thinking about it. But what I'm doing here is I'm noticing that I want to take 7 times 5. And then I want to add 3 to it. And that will give me the number that I should have had in the first place. Right? 7 times 5 is 35. 35 plus 3 is 38. I've seen some students in the past who really enjoy thinking about this as following along, going clockwise. Start at the bottom with the 7. Going clockwise, we hit 5 and 3, and then we go back to 7. All right, so 7, 5, 3, and back to 7. Following the order of operations, multiplication should happen before addition. That's completely a coincidence that it worked out that way, but it's a nice way to remember it. Another thing that we have to worry about when it comes to working with fractions is that division can happen in multiple different ways and give you the same result. 24 divided by 3 is 8. 40 divided by 5 is also 8. So the fraction 24 over 3 and the fraction 40 over 5 are the same fraction. And if we don't have a way of saying we want a unique written fraction for each value, things will get very confusing very quickly. The instructions are changing in language. Some people talk about this process as reducing to lowest terms. Some people talk about this process as rewriting in simplest form. Either way you know it, it means the exact same thing. If we see a fraction and we can find common factors, we can eliminate those common factors and come up with a simpler fraction. So in order to spot common factors, we need to have some ideas about divisibility. There are rules for divisibility for most numbers, but if you know the rules for 2, 3, and 5, you're going to get a very long way. A number is divisible by 2 if it's even. In other words, a number that ends in 0, 2, 4, 6, or 8. Three is an oddball. The rule for divisibility by 3 is that the sum of the digits of the number is divisible by 3. So if you have a larger number, like for example, 72, well, 7 plus 2 is 9, and 9 is divisible by 3. So 72 is divisible by 3. Five is similar to 2 in how it works. A number is divisible by 5 if it ends in a 0 or a 5. There are rules for divisibility by 4, 6, 7, 8, 9, 10, 11, 12, and 15 that I know of. But if you just know these 3 rules, it's going to get you a very long way. So as an example, let's take a look at the fraction 144 over 420. This is a proper fraction. The numerator is smaller than the denominator. But I know that it can be reduced from here to a simpler form. There are lower terms we can write it in. Immediately, I notice that this number is even. 144 and 420 both end in numbers that are multiples of 2, so the whole fraction is divisible by 2. You can find larger numbers that you can divide off if you happen to see it, but if you don't, we can take it one step at a time. 144 divided by 2, you can go off to the side and write out the division box if you need to, but that's 72. 420 divided by 2 is 210. They're still both even numbers, so we can repeat that divide by 2 process again. Again, if you have to go off to the side and write out a long division box, that's okay. 72 divided by 2 is 36. 210 divided by 2 is 105. And finally, at this point, we no longer have an even number in the denominator, so we can't keep dividing by 2. Right? 5 is the thing that I check next, but 36 does not end in a 5 or a 0, so that's out. I guess we could check 3. 3 plus 6 is 9, and 9 is divisible by 3, so the numerator is definitely divisible by 3. 1 plus 0 plus 5 is 6, and 6 is divisible by 3, so the denominator is also definitely divisible by 3. Right? Again, if you have to go off to the side and write out the long division, there is nothing wrong with that at all. But 36 divided by 3 is 12, and 105 divided by 3 is 35. All right. How can we get to 12? Well, we can multiply 1 times 12, 2 times 6, or 3 times 4. How do we get to 35? We can multiply 1 times 5, or 1 times 35. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 times 7, 6 doesn't work. That takes us to 7, which we already named. So 12 is 1 times 12 2 times 6, 3 times 4. 35 is 1 times 35, 5 times 7, and nothing else works. Right? Trick on writing these out. You start on the left-hand side with 1, try 2, you try 3, try 4, you keep going until you get to a number that you've already written on the right column. So you try 1, you try 2, 3, and 4, they don't work. You try 5, you try 6, it doesn't work. You get to 7, 7's already written down. You're done. You don't have anything else to look at. There is nothing else in common. 12 over 35 is our result. Whenever you have fractions, you can go through and do the simplification like that. It's never really a problem. There are a couple of divisions that happen so often in the world, especially in the United States, where we use the US customary system and fractional measurements are much more common than the rest of the world that uses the metric system. But because fractions are so common, it's worth knowing a couple offhand. Fractions of 8. 1/8 does not reduce. 2/8 reduces to 1/4. 3/8 does not reduce. 4/8, 8 is 4 times 2, so 4/8 reduces to 1/2. There's nothing you can do with 5/8. 6/8 is 3/4. Nothing you can do with 7/8. And 8 over 8 is 1. The other family that's useful to know offhand is the fractions of 6. There's nothing you can do with 1/6, but 2/6, both 2 and 6 are divisible by 2, giving you 1/3. 3/6, 6 is 3 times 2 still, this gives you 1/2. 4/6 is 2/3. There's nothing you can do with 5/6, and 6 over 6 is 1. Right. Those fractions are worth knowing. From here, you can get pretty quickly onward to the fractions of 16 and the fractions of 12. Fractions of 16 are incredibly useful in the US customary system because there are 16 ounces in a pound when you're talking about weight, and there are 16 ounces in a pint when you're talking about volume. So fractions of 16 come up very frequently in those two kinds of measurements. Fractions of 12 are useful because there are 12 inches in a foot. And you'll notice that 2/12 is 1/6, 2/16 is 1/8. So if you learn these, getting from there to the 16th and to the 12th is very useful. They come up often enough that they're worth knowing in a lot of contexts. I'm not going to ask you to get that far, but I am going to ask you to know how to reduce these couple of fractions offhand. All right. Uh, with that, I have nothing else to say about fractions at the moment. Take some time practicing converting between improper fractions and mixed numbers. Take some time practicing converting, reducing fractions, and I'll see you in the next video.